Okay, so now we're going to start on part 2 of Project 4. This is the third video for Project 4. And we're going to do variance-covariance matrix first. This first step says, of course, go to the returns worksheet, which is where we start. And on the menu, go to Data, Data Analysis, and we're going to do a correlation matrix. You're going to use the correlation matrix later. We're not doing it for part of the project. But you're going to use it later in answering some questions. So I'm going to talk to you for a minute about the difference between correlations and covariance later in this video. So we're going to go Data, Data Analysis, Correlation. Okay. And the input range is going to be the 5 stocks, the returns from the 5 stocks. I'm going to use all of them. All the way down to, I want to make sure I didn't get the mean. I did. So I'll do this. And make sure to grab also the title so that you have the stock name included in that matrix, because then you're going to click on this, but this that probably won't be checked to start with. This place right here that says labels in first row. That way everything's labeled for you and you can sort of know what you're looking at. It helps you know what you're looking at. I renamed this worksheet correlation matrix, so where it says new worksheet correlation matrix, and it's going to put it in a new worksheet called, surprisingly enough, correlation matrix. So we've got that. And this next step says, so you don't have to do step 4 if you already named the sheet correlation matrix. The next step is step 5. And in the data analysis, we're going to go back to the returns sheet. In the data analysis tab, we're going to choose covariance. So in a previous project, I had students convert the covariance matrix to a correlation matrix. I'm sorry, the correlation matrix to a covariance matrix so that they could see how it was done. But it gets to be a big hassle, and I'm not sure how much learning takes place from doing that. So I did not have you do that this time. You can tell me if you feel like that needs to be done. But I'm going to tell you, I'm going to just kind of show you the difference between the correlation matrix and the covariance matrix. And here we are right there. Labels in first row is checked, and I'm going to put it in a new worksheet called covariance matrix. Okay, so there it is. So let's take a look at the correlation matrix and the covariance matrix and see what those look like compared to one another. I'm trying to get them sorted. Okay, the covariance can be negative, although none of these are negative. It's not particularly likely to be negative unless you have 2 stocks that move in opposite directions. But it's a number that really has no limit in its range. It's kind of difficult to describe. These numbers here on the diagonal are the variances. So the covariance is the way that Love moves with ExxonMobil, for example. So here's the correlation between, or the covariance between Love and ExxonMobil. Actually, it'll be right here, because it doesn't, oops, it doesn't have any data on the upper diagonal. We're going to fill that in, so we have to look at these two, ExxonMobil with Love, and that's the covariance. So it's not really very meaningful unless you look at it compared to something else. So you can see that the covariance between ExxonMobil and 3M is a lot higher than it is between ExxonMobil and Love. You kind of expect that. Airlines are sort of negatively related to oil stocks in general, but ExxonMobil has a lot of other businesses that they do. So it's not a negative correlation. But it's a very small one. 3M, however, probably uses a lot of oil byproducts in their business. So there's a high covariance there. We're going to look at that on the correlation matrix, and we're going to see a little bit more detail and kind of see how that can be interpreted a little bit better. Notice that there's nothing in the off diagonal, so there's nothing up here, because the numbers in the off diagonal match the numbers in this bottom part. So it's basically the inverse, or the reverse. So we're going to flip that and put it up here in the next step. Okay, so going to the correlation matrix. The correlation matrix is, the difference is the correlation actually has a range between, and we're going to call it rho, so it's got to be greater than or equal to, whoops, I made a beta. It's got to be greater than or equal to -1 and less than or equal to +1. So the correlation matrix, the correlation has a range of -1 to +1. So notice that Love, or Southwest Airlines, and ExxonMobil have a very low correlation. In fact, it's pretty close to 0, whereas 3M and ExxonMobil have a very high one right there. So it's almost 60%. So it's very close to +1. So what we can also see is the relationship between the correlation and the covariance. There is a relationship there. The correlation is the covariance of Love divided by the standard deviation of ExxonMobil times the standard deviation of Love. So we can prove that to ourselves. It's equal to the covariance of Love with ExxonMobil divided by the standard deviation of ExxonMobil. So I'm going to have to take the square root, because that's the variance. Oops, 0.5 times the variance of Love and that's equal to the correlation between Love and ExxonMobil. 0.62477, 0.62477. Let me write that so you know what it is. So the covariance, the correlation between Love and ExxonMobil is equal to the covariance between Love and ExxonMobil divided by the standard deviation of Love times the standard deviation. I said standard deviation, I gave you variance. Times the standard deviation of ExxonMobil. Okay? And that's what this cell has in it. Come over here so you can see what's in that cell. And you can see that that's the same. So in general, the correlation between any two random variables is equal to the covariance between those random variables divided by the standard deviation of one times the standard deviation of the other one. So that's a relationship between covariance and correlation. I hope that you get that without doing it, but I don't know that the students were really getting it very well by doing it, to be honest. So I may ask you a couple of questions about that on the exam. I can't promise that I won't, but it won't be computation. It'll just be the relationship. So the advantage of using the covariance, of using the correlation, is that it's bounded. at -1 and +1, and whereas if we look at this covariance between exon level and low, we're not really sure how high that is. So how high is it? You have to look at it compared to something else to see how high that correlation is relatively. So with a correlation matrix, you just compare it to -1 and +1. So it's a little bit easier to see how high the correlation is than it is to see how high the covariance is. Okay, so I'm going to erase all this stuff so it won't stay there.